Hello and welcome back to KXAN Plus. I'm your host, Esmeralda Zamora, and today, if you're watching us live, happy Wednesday. We have our Kristen's Classroom segment, which we have every single Wednesday with our KXAN meteorologist, Kristen Currie. Kristen, thanks for joining me. How are you doing?
Of course, pretty good. Halfway through the week, still some pretty quiet weather out there, but hoping for a little bit more excitement next week.
Pretty dry, right? It's been pretty dry out there.
Yeah, we've been kind of stuck in this pattern of just itty bitty rain chances, and I'm hoping by the time we hit Monday, our first day of fall, we can start to beef those up.
Yeah, I woke up this morning to a notification on my phone from the weather team here, and it said something about rain later this week, and I got really excited.
Yeah, that was me. That was me early this morning sending you your video forecast, which we do. I typically get those out every morning between about 5 and 5:30. So make sure you've got the KXAN weather app. Make sure the notifications are turned on. Only if it's an emergency will I send that notification with the sound. So more often than not, in the mornings, I will do it without a sound. That way, by the time you wake up, whenever that might be, you'll see the notification on there what your weather will be. And again, yeah, it's going to be a little while, a few days before we get some rain, it looks like, but we'll take whatever and whenever we can get it when it comes to rain, given the fact that we've been so dry.
Yeah, that's right. Well, today we're not talking about rain specifically, but we're talking about the introduction to climate patterns. For anyone who doesn't know what that is, what is it?
Yeah, I figured this would be a good topic while the weather is quiet to kind of give an overview, a preview of what climate is, what kind of patterns we look for, and how we use it every day here in the Weather Center, because I think there's a lot of confusion about what exactly that means. So we start first with weather versus climate. Weather is the short-term, day-to-day conditions. So the weather today would be mix of sun and clouds, highs in the 90s, 10% chance of rain. Climate is the longer-term pattern. And it can be anywhere from 30 years worth of weather data, or maybe a season's worth of weather data in some cases, but we're looking at the long term. And what I like to use as an example or an analogy of this when I go to the classrooms is think of weather as what am I going to wear today, and climate as what's in my closet this time of year usually, right?
Yeah.
Because you probably aren't talking about ski pants and mittens in September, right? We're still kind of in that hot season. So that's the difference. Whether short-term, climate more long-term.
And is there a specific season where these matter the most?
As far as the climate patterns go, we'll talk a little bit about how winter, I think, is most impacted by some of the climate patterns. But weather happens every single day. Climate is just a accumulation, a group of that weather day-to-day pattern stuck together, right? So this is just kind of the introduction of weather is what I give you on TV. Yeah. Climate is the big picture. What do we normally see this time of year? More often than not, when we talk about climate patterns here, trends in the long-term data, we're looking at an atmospheric component, so what's happening in the sky, and what's happening down below in the ocean. And the ocean temps in particular have an influence on where the jet stream is. The jet stream is our storm track. Yeah. So depending on whether it's warmer in the ocean than normal, cooler than normal in the ocean, that can have an impact of where that storm track sits over Texas or over the United States. And that obviously has implications on our weather. Does that kind of make sense as far as like what we're launching into as far as climate patterns go and the difference between weather?
Yeah, Rich actually spoke to me and the viewers on Sunday about jet streams because I didn't know anything about jet streams. I'm sure a lot of our viewers were kind of confused as to what they were, so that's where the question came forward from.
Absolutely. Basically a river of fast-moving air way up above us that brings in storms. You can think about it. I call it oftentimes on TV the storm track because more often than not, the jet stream is what brings us those big storms that can really have an impact on our weather. So the first climate pattern I wanted to talk about is probably something a lot of us have heard of, the El Nino Southern Oscillation. This is a kind of a trigger pattern, if you will, because people will ask me sometimes like, is this because of La Nina? Is this because of El Nino? There are certain impacts, yes, but it's hard to nail down exactly is one storm because of El Nino or La Nina. And here's why. If we talk about what the El Nino Southern Oscillation is, we're basically looking at the temperatures of the ocean right near the equatorial Pacific and some of the winds up above. So during the El Nino Southern Oscillation is basically the back and forth of 3 different phases. During an El Nino, we're looking at warmer than normal ocean waters right near the equatorial Pacific. So think like parts of near Mexico and even Central America, that part of the Pacific Ocean. Are those temperatures up there on the surface of the ocean warmer than what we normally see? And normal is established by the 30-year average there, plus weaker easterly winds. We have these winds up above us, way up above us, that are predominantly out of the east. The trade winds is what we call them, if that rings a bell. We typically see weaker trade winds, so not as strong of a wind blowing from the east, from the east. Easterly winds, yes, to the east. From the east, I should say. Let me think about that. I'm like, trade winds from the east, yes. And when those are weaker, that typically gives us some drier conditions over Indonesia, so on the other side of the Pacific, and wetter conditions closer to home.
Our side, yeah.
On our side, yeah. So that means that kind of pulls the jet stream down. During El Ninos, we typically see, in general, a wetter season here in Central Texas. And the reverse is true for La Nina. Cooler waters right next to Mexico and Central America, right on top of the ocean there, and a stronger easterly wind. That typically means wetter conditions on the other side of the basin, drier conditions here. Now, for the past few years, we've had back-to-back La Ninas. If you remember 2022, 2023, we've had some pretty big La Ninas here. You've also noticed we've had some pretty big storms in those years too, right? Yeah. 2021, 2022.
And some freezes here and there.
That's what I mean, yeah. And so we're talking here in general, big picture, not individual storms. You can absolutely still have some big time snows during La Ninas. We're talking about in general.
The pattern
is favoring drier conditions here at home. And then there's the neutral phase. That means our surface temperatures out there in the ocean next to Mexico, Central America aren't really warmer. They're not really cooler. They're right where they should be. That would be case 1 for a neutral phase. Or there's a disconnect, meaning the ocean temperatures are maybe a little bit warmer, indicating El Nino, but the winds aren't cooperating.
So they're not talking to each other, right?
Right, yeah. There's some sort of disconnect. In the case with the La Nina, it'd be like, we're seeing those stronger easterly winds, but the temperatures in the ocean aren't really cooperating. So you can have that as a neutral phase too. But basically, we're looking at what are the temperatures in that sweet spot of the Pacific? What are the winds up above? And that can tend to mean wetter or cooler conditions, more likely than not, for parts of North America. And I'll show you that here in a second, but this can flip every 2 to 7 years. Later today, Chief Meteorologist Nick Bannon is actually going to give us an update on what are the odds that we do get back into La Nina later today. But depending on the ocean temperatures and the winds, that's going to move around that jet stream and kind of not lock it into place, but favor it in a certain area that unfortunately isn't great for wetter and cooler conditions here at home. So a La Nina pattern would be this: the jet stream a little too far to the north with those cooler waters out over next to Mexico and Central America, leaving us on the drier and warmer side. This would be for the winter season. And you asked me earlier, what about what seasons here are most affected?
Yeah.
For the El Nino Southern Oscillation, this is more of a winter trend than it is any other month. We see bigger impacts or more effects of the El Nino or La Nina pattern during the winter season more than any other month.
Well, Kristen, before we move on, we do have a viewer question from our Facebook viewers.
Sure.
This is from Victor Lovey. And they said, Kristen, what is your take or explanation on the West Texas weather pattern in May of 1980? I was farming, and when Mount St. Helens in Oregon erupted, large cumulus clouds would hover over West Texas and only rain a few drops. 1980 West Texas Midland area only received 3 inches total of rainfall. Needless to say, not enough to raise cotton that year. What are your thoughts? Much appreciated.
Yeah, I'd have to really go back and look at the records, considering it's, 40 years ago and not our area. But I would have to go back and look. I will tell you, there's likely not any sort of major correlation as far as immediate impacts go when it comes to rainfall in a volcanic eruption. And I just say that because in general, that's a volcanoes, if they're big enough, they can cool the planet. But as far as not receiving any rain from a cumulonimbus cloud right after the eruption, I really wouldn't think that would have, those two would be correlated. Yeah. I can tell you, when sometimes you see what look like big rain clouds over volcanoes, those are big pyrocumulus clouds, we refer to them as. And it's that intense heat that gets shot up into the atmosphere and makes these big clouds that can sometimes even have lightning within them. But they're a certain type of cloud. That pyrocumulus cloud is different from a nimbostratus cloud or a cumulonimbus cloud that does deliver rain for us. So that would be something I'd have to look into. And that wouldn't be necessarily related to climate. Again, if it's a bigger eruption from a volcano, sometimes we can see little blips in our temperature trend as a globe. But I wouldn't think if it was a volcano eruption, especially so far from home, that we would see any sort of major impact here. But something to look into maybe for a different Kristen's classroom. I will tell you, when it comes to hurricanes, too, just to put a bow on this for the El Nino Southern Oscillation, during La Nina, we tend to see more hurricanes because of weaker winds out in that perfect slot where hurricanes like to develop here. So when you have really strong winds coming at different directions and different heights in the atmosphere, hurricanes don't like that. I think this is too much. It works to destroy the organization of the storm. So if there's less of those winds and there's a very conducive environment in the atmosphere, these hurricanes have nothing to stop them. We see fewer hurricanes, though, on the opposite side, on the eastern Pacific side. So,
and what was the case this year?
So this year we're still kind of in it. This year we're still kind of in it, and we are in right now a neutral phase with the El Nino Southern Oscillation. So we're not in an El Nino, we're not in a La Nina, we're kind of in between here. So there's no strong correlation yet. But the reason I bring this up is because I think Chief Meteorologist Nick Bannon tonight is going to have some different news for you. We got a brand new update. I don't want to spoil it. I don't want to give it away just yet. But he's going to bring you some new information, the latest update that we got regarding our El Nino and La Nina odds. It has a little something to do with the La Nina that I'm talking about today. Climate pattern number two of three that I'm going to share with you today. The Madden-Julian Oscillation, not quite as well known as the El Nino La Nina pattern. The Madden-Julian Oscillation is basically looking at precipitation associated with this east-moving cluster of clouds, rain, wind, and pressure differences. So think of, put very simply, a big group of very stormy weather. Convection is basically thunderstorm development. Think of a convective oven, right? The heat goes from the bottom to the top. You see this convection process here within the atmosphere every single day. But convection is phase one of this pattern, and that's associated with more rainfall. Suppressed convection, so suppressed thunderstorm activity, means less rainfall. This back and forth of the MJO, the Madden-Julian Oscillation, as this big cluster of storms and showers moves around the planet every 30 to 60 days. However, there can be more than one of these clusters. So that's what's tricky is we watch these clusters as they move, and kind of splits the planet in half, move these clusters of storms and showers around. And sometimes if we're in a convective phase, that means we're more favored for thunderstorms. If we're in a suppressed phase, we're less conducive for that thunderstorm activity. When I look at, and I know this is really in the weeds here, but just briefly talked about the difference from normal rainfall. This is what you're looking at now, as you can see, or maybe you can't. I know it's tough to tell because this is so small. On the right side would be, Africa. You can see the tail end of Central America there. The browns indicating drier than normal, the greens and the blues indicating wetter than normal. If you go from top to bottom, do you see how that green and it's really the brown kind of moves eastward, kind of moves across the map there?
Yeah, it kind of switches positions with the green.
Yeah, so we're looking at all the MJO events, all these clusters documented from 1979 to 2012 during that November through March timeframe. So again, we talked earlier about what season are these most, watched, and that is that time frame, November, March, for the Madden-Julian Oscillation. And they're looking at where are these clusters and storms and showers as they move across the planet here every 30 to 60 days from start to finish. So I think this is really interesting. What is crazy is, you think of El Nino, La Nina as that can be a whole season, right? Or sometimes a few seasons. And these are maybe
For
1
us
to 2
here.
months.
Yeah.
Oh, anywhere in the world. The El Nino, the La Nina, when it comes to Indonesia, the western side of the Pacific and the eastern side of the Pacific, we're looking at 1 to maybe a few seasons, whereas the Madden-Julian oscillation is about 1 to 2 months. Yeah. So we see more of these. And this is what I'm talking about as far as climate pattern goes, not day to day. Day to day's weather. Climate would be for El Nino,
Extended
a season to a few seasons. Yep. Madden-Julian would be 1 to 2 months, and we repeat that cycle. The last one would be the Pacific Decadal Oscillation. I think this is maybe a little bit more easier to understand. It's kind of like a long-lived El Nino. So El Nino proper, 1 season to maybe a few seasons. This is every 20 to 30 years that we're looking at these big blobs of warmer or cooler than normal waters in different parts of the Pacific Basin. A positive climate pattern of Pacific Decadal Oscillation would be cooler waters up in the northern Pacific, warmer waters next to home in the North American coast, and then below average pressure up there in the North Pacific too. And then we just reverse it with the negative PDO. Warmer waters up there in the North Pacific, kind of cooler next to California, and then above average. Above average pressure would be like high pressure sitting over the North Pacific. And like I said, this flips every 20 to 30 years. And I love this graphic put out by the National Centers for Environmental Information here, because you can easily see us going back and forth, right? From the positive to the negative. And it's indicating the years on the bottom here. So it'd be, 10 to maybe 15, 20 years, we'd see the negative. Then we go back to the red and we go back to the blue. This is going all the way back to the 1850s here. And they can actually measure the height of the ocean surface using satellites that actually give us an idea of what the temperature is, because warmer water takes up more space. And so if it's taking up more space, then the height between the satellite and the top of the ocean is going to be less than where if it was cooler and the ocean particles are a little bit closer together and that ocean level's a little bit lower, then you're getting farther away from the satellite. So that's how we can kind of, when we don't have little thermometers or little buoys out there in the ocean, we use the height from the satellite sometimes to figure out, is it warmer and there's a little bit more of that ocean up top, or is it cooler and the ocean's coming down a little bit? So all that to say, these 3 climate patterns are something that we look at when it comes to big picture, right? Whether it's El Nino, La Nina, every couple of years, or the MJO every couple of months, or the Pacific Decadal Oscillation every couple of decades. What are we in right now? We are in a neutral phase when it comes to that El Nino pattern, with an La Nina expected by winter. There's odds of that happening, which Nick Bannon will talk about tonight. We're in a very weak Madden-Julian oscillation, the big cluster of storms and showers that rotates around the planet. Very weak correlation right now. And then when it comes to the Pacific Decadal Oscillation, we're on the negative side of things right now. So that doesn't tend to favor a whole lot of storm convection or stormy weather. But it is interesting to note, because all of that put together, all of these climate patterns, all of the climate averages, the 30-year weather data we sandwich into one, gives us these. And I'm sure these have looked familiar, right? When we get up on air and we say, okay, here's your fall outlook, September, October, November, and it's showing drier than normal conditions over Texas. What the Climate Prediction Center is doing, who's in charge of putting out these maps for us, they're looking at, what phase are we in with El Nino, La Nina? What phase are we in? Where are those clusters of storms and showers around the planet? Or what phase are we in with the Pacific Decadal Oscillation here? They're looking at all the climate patterns and saying, okay, well, because we're in a neutral, maybe going to La Nina, we don't have a strong correlation with the MGO, we're thinking drier than normal conditions. That's the peel behind the curtain, if you will, of where all of our outlooks, our seasonal outlooks, our 2-week outlooks, our annual outlooks, all of that comes from. So the fall outlook, the drier than normal, I mean, we are transitioning into a La Nina, so it makes sense that we would maybe be drier than normal and warmer than normal. So I know that was really in the weeds, but hopefully, and Esme, tell me the truth, hopefully that makes sense as far as, these climate patterns, these different big picture weather phenomena, if you will, over a long scale can have give us an idea of what our different seasons may look like, or what a few seasons may look like here at home.
Yeah, you broke it down very well. It's very interesting to see all that it takes to get a weather outlook that we get either for fall, for winter, for summer. But you showed us kind of the patterns that we're following current times right now. Does it ever occur where those patterns vary within those categories?
Absolutely. I mean, you think about during, let's say, for example, an El Nino, right? An El Nino tends to favor wetter weather here in Texas during that time. Can we go 2 weeks within a month without rainfall? Absolutely. And what's tough,
we have.
and we have, absolutely. And what's tough about that is there was no El Nino or La Nina that is exactly the same. And we've had some big El Nino events, going back to 1998 and before that in the 80s, and every rainfall pattern is a little different. They generally have the right idea of more rainfall, but never the exact same. So that's why it's tough, because we can say in general, when we see these temperatures in the ocean and those kind of winds up in the atmosphere, and that has been the case for a few months, then that means wetter weather in Texas. How much wetter? We don't know.
We don't know.
Right? So that's where the caveats come in of, yes, these can fluctuate. We can see different intensities of El Ninos. We can see different lengths of La Ninas. I mean, all of that is possible within these climate patterns, especially you think about the Pacific decadal oscillation. Every 20 to 30 years this flips, right?
Yeah.
So that's a long time of data you're having to collect before you can officially say, okay, I think we're in the next phase now. But all that to say, with these outlooks, we look big picture, and it could be very, very well by different meteorologists. I tend to look big picture, and then I go microscopic to the 7-day, because really the weather in Central Texas on this day is very microscopic when you think about the weather that's happening in the entire
all
planet.
around us.
Yeah, right? And what we normally see. So this is weather, your 7-day weather forecast, whereas this would be your climate outlook.
Or your season outlook.
Seasonal
right?
outlook, yeah, that has to do more with the climate of the fall. 7-day forecast would be weather, very short term,
Current.
very day to day.
Yeah.
This wouldn't be quite current, because we're talking about 95 this afternoon, and it's not a terrible looking 7-day. We've seen it a lot worse in September.
I don't see any triple digits on there.
Exactly,
so
that's
I'm happy.
exactly what I'm talking about. So, mid 90s, this is your real 7-day forecast. We've got showers and storms, as you mentioned at the top, Monday, Tuesday. But I wanted to kind of broaden that out and maybe talk a little bit to the big kids there about climate patterns, because there's a lot of discussion right now about changing climate. And what that is we're kind of loading the dice of the atmosphere with these greenhouse gases. We're messing with the winds, and we're messing with the atmosphere, because we're putting a lot of heat trapping gases up top. And now we're like, well, okay, wait, if this is messed up, then what's the ocean going to do? And that's why we're seeing, our planet saying, hey, wait, we're a little too warm up here. The ocean's got to catch up.
Unbalanced.
Right? There's an unbalance here that the planet's trying to fix. And sometimes that can happen in, extreme weather events or these prolonged periods of drought. That's basically what climate change is, right? And whether it's anthropogenic, human-induced, or natural climate change like volcanoes, it's that imbalance of what is normal over a big picture. So that's kind of the heavy nuts and bolts. Now, I wanted to show you, before we lose time, some really fun pictures. Can we do that?
Yeah, let's do it.
Okay.
I can blow them
some
up.
really fun pictures of some school visits that I did recently within the last week, because this is the first graders of Sycamore Springs, which we didn't talk about climate patterns. With the littles, it's a little bit more like you see seasons, right? High temperatures and low temperatures. This is the teaching staff at Sycamore Springs in their first grade. But this is where it starts. And for me, this is where
so sweet.
It begins with talking about what a thermometer does and what kind of weather we see where we live. I don't tend to go too much into the climate and the climate change with the littles, but I will for the bigs. This is Aiken Elementary up in Leander ISD. I had the opportunity to talk with their second graders, and we did the same thing. A lot of what we discussed during these school visits are safety. Weather safety, during floods, during tornadoes, during all sorts of different weather hazards that we could potentially see. And then yesterday it was a homeschool group that came in to a studio, and we did the same thing. The studio visits are a little fun. Maybe a little more fun because
I remember hearing yesterday them asking you if they could go upstairs.
Yeah.
to tour upstairs.
Yeah, and you can see this group has, littles to bigs, and sometimes that could be tough because you don't want the littles to be running around with all the expensive equipment. But for the bigs, that's sometimes the most exciting part,
Yeah.
But they're a lot of fun, and what I mean by maybe a little more fun for the studio visits is I turn on the cameras and we play on the green screen, and we do a lot of that. But a lot of what I focus on in these school visits would be safety, weather safety, especially coming off, a devastating summer of floods. That the flood conversation has happened a lot, but the climate patterns of El Nino, La Nina, the Madden-Julian oscillation, even some of the Pacific Decadal oscillation, all of that plays into a 7-day forecast like this or those outlooks that we show you.
Yeah, I love that school is back in session because you're back in the classrooms. And I wish as a student I knew, hey, these seasons are determined this way and your 7-day forecast is determined a different way. That's very useful information.
And I think even just, when we do show those outlooks of like, here's what we think October is going to look like. Now, okay, they're looking at some of the temperatures in the ocean. They're looking at the winds, what the winds are up above. And all that, like, are we seeing a really strong trade wind, the wind coming out of the east? Is that cooperating with the ocean down below? All those little things that come into consideration when you're trying to look beyond 7 days. Because let's be honest, when it comes to a 7-day forecast, really the 48 hours is the most accurate more often than not. Once you get towards the end of the 7-day, data gets a little fuzzy. We're just not quite there yet with our technology, with our understanding of everything that happens in the atmosphere and the ocean. So when you're trying to forecast what October, November, December is going to be, it can be really tough. So that's why we use these big climate patterns to give us an idea of, okay, last time we were this warm in the Pacific, we had a really strong trade wind coming out of the east. We actually saw a lot of wet weather here in Texas. So we'll maybe say it's going to be wetter than normal. Can it be wrong? Absolutely, right? We don't know everything about...
It's always changing too, right?
Yeah, we never know everything about and it can change. I mean, think about the fact that if we didn't have those big floods in July, we very well could have been in the triple digits for the last 3 weeks. Yeah. Part of why we've been cooler, if you will, than what a lot of people were thinking this summer would be like is because we have water in the ground. And most of that, the heat energy that comes from the sun, yes, goes into warming the air, but some of it gets pulled into evaporation into that water, and not as much goes into the air. So that's kind of why I think we've been avoiding a lot of these triple digits, is because we've gotten so much of that rain, not only in July, but May and July were very wet for us. And so once we got into the bulk of the summer heating, not all of that sunshine went into warming the air like it normally does. Some of that sunshine got pulled in the ground to evaporation, and sometimes that's just enough to keep that temperature down a few degrees.
Yeah, I know this summer we did feel the heat, but it wasn't as often as we did last summer.
Yeah, I mean, we typically average about, 29 triple digit days, and I've got the graphic pulled up here. So far we've had 21, so we're not even at
How
normal.
many did you guess at the beginning of
summer? Girl, so many, like 50 something. Because
oh my God.
There's just no way when it comes to extreme weather. I would say more often than not, like 95% of the time, we will never be able to forecast extremes ahead of time. You know, it's the same thing with the winter 2021 storm. 6 days below freezing in Texas. It's never happened before, you know? So our computers are going to struggle with it. We're going to struggle with it because you say, no, that doesn't happen here. Minnesota, sure, but Texas, that doesn't happen here. So our
cool
forecasting,
summer in Texas? No way.
Exactly, right? Our forecasting is going to reflect some of those biases, but that's where that wrench with the climate change comes in. When we're starting to mess with the factors of what we normally see, then we're not going to see the normal, right? So the flooding, I think, had a huge impact on the number of triple digit days we have and have not seen, to be frank. And I also think, it's maybe the reason why it seems a little cooler than normal. I mean, our temperatures What's interesting is still mid to upper 90s. I mean, that's hotter than normal. We've been hotter than normal for quite some time too. I can even show you.
But for a week ago or 2 weeks ago, we had pretty cool nights and mornings.
Yeah, and that's the thing. Those stick out, I think, more than the warm nights will, because if I show you here, the calendar is what I'm looking for. This is September. We still have had way more days hotter than normal than not. You know, and you think of it and you're like, wait a second, it didn't feel
like that.
Yeah, I mean, we had 104 4 days into the month. We've had a handful of cooler than normal days.
Yeah.
Saturday, Sunday, that first weekend of this month was kind of overcasty, a little drizzly.
Mm-hmm.
People, and this plays into the social science of meteorology, people will stick to that and they'll think, oh yeah, it hasn't been that bad. And you look at the calendar and you're like, wait a second, like we've had 99, 104, 102. That's hot, you know?
It's kind of like we suffer through the day and then we forget about it.
Right. And that can be said about anything in life, right? Sometimes you get stuck on the bad things and you overlook maybe some of the good things that did happen. Mm-hmm. It's just human habit, I think, to kind of default to, I wish it didn't happen that way. And you're like, wait a second, this and this happened.
104 on a Thursday?
Right. This and this happened in my favor, and it can be applied to weather, right? Yeah, we had a really good first weekend of September. It was nice and rainy and cloudy, but we also had quite a few days where it was a little toasty and sweaty. I think the big difference that I've noticed this month is the humidity hasn't been quite as bad the last couple of weeks, and that, in my opinion, makes all the difference, right? Mm. At 95 degrees and dry is very different from 95 degrees and very humid. And so I think that has been more of a noticeable kind of, people are actually feeling and remembering that than anything else.
That's interesting. Well, thank you so much for sharing the insight into how that outlook is forecasted.
Of course.
And the comparison between that and our 7-day forecast. That's, I know a lot of our adult viewers are questioning that too when they see those outlooks come out.
And I will say this, I've been doing this for 10, 12 years, like of studying these kind of things. So I don't expect you to get it in a 30-minute chat. It's very in the weeds and it's very complicated and difficult, I think, to capture how much goes into it and big picture patterns. But hopefully that gives you more of an idea of like, okay, that's how that's made. That's why they think that the way they think is because they're looking at things in the ocean and things in the atmosphere.
And these are the things that we need to have the summer that we want, right?
Yeah, I mean, Mother Nature's kind of in charge of that, right? She's the one who decides whether we're going to be hot or cold. But it gives us an idea of what Mother Nature's thinking. I will say, it gives us an idea of what her plans are exactly.
Well, you published this article, and it's on our website, KXAN.com. Tell us what's in the article.
Yeah, so I kind of break it down a little bit more as to, like, what is an El Nino? Where are those temperatures we're looking at in the ocean? And some different graphs from, or visuals, I should say, from NOAA, National Oceanic and Atmospheric Administration, that we talked about how I think it's, in my opinion, easier to see on a map what those waters are doing and how it correlates to rainfall. But if you've got questions, let me know about this. Again, this is big picture, so I don't think you're not going to look at the 7-day and think, oh, this is because we're looking at the positive PDO. Like I don't expect that. Just kind of giving you guys a behind the scenes look at the forecasting of what goes into some of those longer term outlooks.
Well, thank you for sharing with us, Kristen. And if anyone is interested in getting more in the weeds, that article is on our website, KXAN.com. And Kristen and I will see you next Wednesday. Thanks for joining us, Kristen.
See you then.